Everyone thinks static cling is just annoying. They're wrong. It's a tiny lightning storm. It's a familiar ritual, isn't it? The dryer buzzes, you pull out a load of warm, clean laundry, only to find your socks aggressively embracing a t-shirt or a skirt stubbornly attached to a sweater. This isn't just a minor inconvenience. It's a silent, everyday physics lesson playing out in your utility room. What's really happening here is a miniature drama of charged particles, a ballet of electrons, all orchestrated by the very nature of matter itself. We're talking about the subtle forces that govern everything from the spark you get touching a doorknob to the structure of every atom in the universe. To understand static cling, we first need to briefly revisit the atom. Remember those tiny particles with protons, neutrons, and electrons? It's the electrons, the negatively charged ones, that are the key players in our static story. They are the ones that can be gained or lost, creating an imbalance. When your clothes tumble in the dryer, they're not just getting warm, they're rubbing against each other over and over again. This friction, this constant contact and separation, is what scientists call the triboelectric effect. It's the same principle behind rubbing a balloon on your hair. Different materials have different personalities when it comes to electrons. Some materials, like wool or nylon, tend to give up their electrons easily, becoming positively charged. Others, like cotton or silk, are electron-hungry, readily accepting them and becoming negatively charged. So, as your wool sweater rubs against your cotton t-shirt in the dryer, the wool might lose electrons to the cotton. Suddenly, the wool sweater has a net positive charge, and the cotton t-shirt has a net negative charge. They've essentially become tiny magnets, but with electrical charges. And just like magnets, opposite charges attract. This is the fundamental force driving static cling. Those positively charged clothes want to stick to the negatively charged ones. It's an invisible embrace, governed by the very laws of electromagnetism. Humidity plays a crucial role in this everyday phenomenon. Water molecules in the air are polar, meaning they have a slight positive and negative end. These water molecules act like tiny conductors, helping to ground the charges, allowing them to dissipate back into the air or other surfaces. That's why you experience more static cling in the dry, winter months. The air lacks sufficient humidity to neutralize those charges. The electrons have nowhere to go, so they build up, creating a more pronounced electrical imbalance and consequently more cling. Think of it like a crowded room. In a humid environment, the door is wide open and electrons can easily leave. In a dry environment, the door is mostly shut and electrons get stuck inside, creating a buildup of energy. So what about dryer sheets? How do these unassuming little squares combat this electrical dance? They don't magically remove the static. Instead, they work by depositing a thin, waxy, positively charged coating onto your clothes. This coating helps to neutralize the negative charges on your clothes and makes all the fabrics more uniformly positively charged. Since like charges repel, your clothes are less likely to stick to each other. It also reduces friction, further preventing charge buildup. Another common household item, white vinegar, can also help. Adding half a cup to your rinse cycle acts as a natural fabric softener, reducing the friction between clothes and thus minimizing the triboelectric effect. It's a less chemical approach to the same problem. Even something as simple as a wadded-up ball of aluminum foil can help. The foil is a good conductor, attracting and neutralizing stray electrons as it tumbles with your clothes. It's a temporary but surprisingly effective solution. But static cling isn't just a laundry room nuisance. This same principle of charge separation and attraction is at play in many other areas. Think of dust sticking to your TV screen or the way a balloon can stick to a wall after rubbing it. In industry, static electricity is a serious concern. It can damage sensitive electronics, ignite flammable materials, and even cause dangerous sparks in environments like chemical plants. Understanding and controlling static is vital for safety and efficiency. On a grander scale, lightning itself is a massive display of static electricity. Ice crystals and water droplets rub against each other within storm clouds, building up immense positive and negative charges until the potential difference becomes too great, and asterisk zap asterisk a bolt of lightning strikes. So the next time your favorite shirt stubbornly clings to your pants, take a moment to appreciate the invisible forces at work. It's not just annoying, it's a profound demonstration of the fundamental physics that shape our world, from the microscopic to the majestic. It's a reminder that even in the most mundane moments, there's a universe of scientific wonder waiting to be explored. What other everyday mysteries are hiding in plain sight?